Making 2 injection molds in 2 days and breaking a few miniature end mills, and why and how to fix it. Welcome to another episode. So Jack from ModMount contacted me again, and he wanted a couple new injection molds. Now, Jack has a tendency of designing injection molds that require fairly long reach, small end mills, and this was no exception. In fact, I had to order some new end mills that were even smaller than I used before. So the last time around, I was able to use long reach 1/16 inch diameter end mills. This time, I had to order some 0.050, so 50 thousandths of an inch diameter end mills that have a 0.45 inch reach, both a flat and a ball end mill, to be able to complete this project. And as you'll also see, I ended up having to use both a 20 thousandths inch diameter and a 15 thousandths inch diameter to be able to mill out some of the details in between the lettering. I also ran into some issues where I was breaking some end mills, and now that I understand a little bit more about what I was doing wrong, it's pretty obvious, but this is the type of lesson where it's easiest learned with a little bit of pain, so I'm not likely to forget this lesson in the future. Anyway, let's get started and make a couple molds, and I'll show you how to improve your chances of, or reduce your chances of breaking small end mills. So Jack sent me designs for the A and B part of the mold. They're not complete. There are some details I need to add. So the first thing I do is I create a new file, which I call mold, and then I want to pull in the A and the B. And I use insert derived because that will allow me to make changes to these parts. And then what I want to do is select the whole thing there. So now I've got the first one in there, and the next thing I want to do is add the second one. So I'll say adapter B. Okay, so select this. I'm not quite sure what I did there, but they're both in here now, so I can show and hide them, and that works quite nicely. What this allows me to do is to go in here and make changes. So for example, I need to add some holes in here that will be the separator for the separator bars that will push the two mold halves together when he basically lowers the platen. So I can now go and make those changes directly in here by adding sketches and doing all of the other Fusion 360 types of operations without impacting the original files over here. The other thing is these files come in with the measurement of meters, units of meters, because of the program that he's using. So I can change this to inches, and now for this assembly, and now everything comes out in inches. So I'll go ahead and make changes to this file and then start on the cam. I just noticed one thing, which is that this one is not 5 inches across. The other ones are. So I'm going to go ahead and back up, and then what I can do is increase the size of this. So I'll go ahead and add a sketch here, and then select the select the perimeter. And then I'm going to draw another rectangle with center around like so. I'll make the two sides equal, and then I'll make this 5 inches. Okay, so then I can extrude that border all the way. Oops, didn't like all the way. Okay, so I'll do two object. and now it's 5 inches on the side. I want to do the same thing with the top, so I'll go ahead and select the top and show this sketch again. And then I can extrude that sketch to the top. And now they're all 5 inches. Okay, and then I can advance the... There we go. That looks much better. Here I'm adding various other features that I need, such as on the top and the bottom there's an alignment hole on one side, and on the other side there's going to be the sprue that injects the plastic into the part, and various other elements. For this particular one, you can probably see it coming and going. I'm using cone-shaped alignment pins and a cone-shaped depression for the two halves to align them together so that they are really easy to put together and pull apart, and there is no binding when it happens. For my next mold, I need to mount a much larger piece of aluminum into my vise. This is 5 inches by 5 inches by 1.5 inches. And I was trying to figure out how to do it, and then I remembered I had these vises that have basically teeth that bite into the bottom. And the top right here is ground very precisely. So it'll register on this. And then I could put this on the outside here, so now that it'll just fit in. What I need to do is pick up the Z0 here. So I'm going to do that next, so that I have a new G54 Z0 or G54 Z offset. So the first thing I'm going to do is I'm going to put in the Heimer edge finder. So I'll go make sure this is in hand jog, press tool release, and then put in the Heimer. Oh, and what I want to do is, if we go to offsets here, so what I want to do is record G54Z, because this is off of the parallels, and I want to be able to just type that back in the future, rather than have it to measure it again. So I'm going to write that down. So let's see. That is 3.4912. Okay. Now I'm going to jog over to the table with the Heimer. I'm also going to write this down so that I don't have to find the Z0 for the table each time. One of the things I've discovered is that it's extremely precise, the homing on this, so I can rely on this number every time. So if I look at the machine position for Z right here, this is what I want to write down as well. So that is minus machine 7.218. Okay, so, oops, that sticky pad is not very sticky, so I'll have to tape it up somewhere, but at least I have those numbers for the next step. So now what I'm going to do is try to pick up the top of the ground surface on these. I'll use this one here, and I'm not sure I can pick it up. I'm going to give it a try. Yeah, I'm not sure I can. I'm going to do it on the end here where I can see it pretty well. I'm going to move over until I start to hit that. Oh yeah, that'll work. All right, so this is the top, and this is the machine coordinates there. So what I want to do is basically the difference is between this one and this one is going to be a positive number. So what I'll do is I can just subtract those two numbers without taking the sign into account. And so that means what I can do is I can do 7.2188 minus 3.3652, and that's what I want to enter. Interesting. I did not do that correct. This is not. Okay, let's try that again, because 7 minus 3 is definitely not 0.8. So I'll clear that. Let's try it again. 7.2188 minus 3, I'm looking right here, 0.3652, and that looks better, 3.855. And it's higher than the parallels, so that actually looks correct as well. So I'll type in 3.8536 and then F1, press Y. I know it's there. Let me get rid of this so you can see it. And now that says 3.8536. So I'm just going to do that calculation again to make sure I got it right. 7.288 minus 3.3652 and 3.8536. Okay, so now I have the Z0 position set for G54. So I'll raise it up now and put my tool away. The next thing that I'm going to do is to make sure I have all the correct tools in my machine. And in a previous episode, I ran into an issue because I didn't. So I've printed out a setup sheet that has all of the tools. So I'm going to go through and make sure that they all match. Like tool 1 is a 3/8 inch end mill, which I know to be true. 3 is, anyway, I'm going to go through, check these all out. And I do know that I'm going to need to change some of these out. I wrote it down on a sheet of paper. So these are the ones that I have to put in, which means I have to take out 14, 17, and 18 I'm going to change, and I'm also going to change 12. And put in the new tools that I need for this job. Basically for this I'm going to put in place a 20 thousandths of an inch diameter flat end mill. Then down here I'm going to have two 40 thousandths inch very long reach end mills that I need for this one. Because, 50 thousandths, because the 1/16 inch long reach that I had are too long. And then the last thing that I'm going to put in here in this slot is a drill that I can use to drill all the way through the stock. Okay, so first I'm going to, looking at my list, I'm going to start with 12. So I have the engraving cutter in there right now. So I'm going to say T12 and then change to that tool. So I can pull that out. And then I'm going to go over to my bench and take this tool out and put the other tool in. All right, so I'll start by putting this tool in and then loosen it. Okay, so I'll take out my engraving cutter. And then I've got this really tiny 20 thousandths of an inch flat end mill that I'm going to put in. And this doesn't have to be really tight. So that should do there. I'm going to do the same thing for the other 3 end mills and mount them in the machine and then start setting the tool height. Okay, I'll put this one back in. And then the next one is number 17. Okay, and I've got the 80 thousandths, I think, diameter end mill in here, so I'll take this out and swap this as well. And I'll keep doing that for the other tools. I lost audio for this segment and quite a few segments afterwards. What I'm doing here is explaining how I use the magnetic tabs. I put these tools into the machine, but I have not set the offsets. So what I've done is I've moved the magnetic labels to the right to remind me that I have not set the offsets. Once I set the offset for each tool, I will move that label to the left so that I have a record of what I've set and what I haven't set. All right, I'm going to start with tool 12, which is the 20 thousandths inch diameter one. So I'll say tool 12. And I'm going to pull out my tool setter and, let's see, hand jock. Make sure I clean off the table where I'm going to put the tool setter. Okay, and then I'm going to bring the tool down and bring it over. I'm going to make the movement smaller so I don't accidentally crash it. Bring it down, and there we go. I'm going to bring it down slowly. You can see the needle's moving, and so I'm going to change it to 1/10,000th of an inch. Okay, that looks good. So what I'll do is I'll make sure, okay, it's on 12. And I'm going to do tool offset measure. And then I need to subtract 4 inches. And that looks correct. So now what I'm going to do is I'm going to move it up in Z. Okay, I'm going to move it faster. And then over here, I'm going to move this in to indicate that I've measured tool 12. So next is tool 14. Oh, sorry, I forgot to do something. Just 12 measure. Okay, then let's go out. Okay. Now I can move this over and get two tools. I thought I captured the footage showing the end mill actually breaking. Unfortunately, I didn't. I also lost the audio in this segment. This was a long reach end mill, and I'll take you to the computer now to show you why this end mill broke. The tool that broke was tool 18. So coming down here, we can see I have a scallop operation, and the scallop operation goes all the way along this curved surface right here. The problem is, at this point, that curved surface hasn't been roughed out. That's done by the contour operation that I had after the scallop operation. So to fix things, I just need to change the order of those two operations. So I have the contour first, and then the scallop second. That's what I meant to do, and that's why it broke, because it just couldn't take the load. This is the final result. I had to use a 28 thousandths inch diameter, or about 0.5 millimeter diameter, to finish removing the material between the letters, because the letters were pretty small and close together. It was tool number 10 that broke, and I was watching it as I went along here, and that part was fine. So at some point, pretty soon, I think it's going to be plunging into this area right here. Let me change from comparison to operation. So this is showing that I just kissed this area right here. So if we go back just a little bit, okay, you can see this is all green, which means it's the previous operation. But if I come in here, let me speed it up a little bit. Okay, this time is fine, but the next time it comes around, okay, so I'll slow it down. And what you're going to see is when it comes right in here, which is where I saw it break on the video, while I was videoing it, so you can see right there it did a gouge, and that's why it broke. And the problem is that I'm doing a horizontal strategy before I did a contour strategy. So what I need to do is do some work on this to make sure that I have a contour strategy to clean up these faces before I get to the point where it tries to cut into there, because as you saw, it was gouging. I actually made quite a few more changes than just the one I described, because I discovered that the order really wasn't very good. So one thing, I moved the horizontal up to basically clean up the floor around here, and then I added a contour here to cut out the material, and the contour goes down to this material right here, so it doesn't go all the way down. Then this is the horizontal I had before, same contours as before, and then everything is fine after this. So I did a simulation, spent a lot of time going through this, looking at this, and this should all be fine now. So what I'm going to do is, since I finished the adaptive, is I'm going to select everything from here down, and then I can post that. And when I post that, it will only do those operations, so I don't have to start from the beginning. That's what happens when I forget to renumber a tool, which is why I'm using tool 21. And you can see right here, it's pretty clear that's what the problem is. So this is my 50 thousandths diameter flat end mill. And so that means what I need to do is take a look to see which, okay, that's tool 17. So I just need to rename this. Oops, edit tool was the one I wanted. And then change it to 17. Okay, so I'm just going to double check. 50 thousandths flat end mill, 50,000, okay, yes, they are correct. So that means what I need to do is repost these, and then I can finish up the machining. Okay, so let's see how these two mold halves fit together. I want to check the alignment. So I'm going to put this on here first, and then hold it there. And then look underneath. And it doesn't quite go together. I think the problem is that there's a little bit of a lip there. So I'll need to come back in and machine that out, but otherwise it looks good. So I'll take this out. Okay, so now I'll put in the blank that I already prepared for the next part, and I can tell it's a blank because I have this dot back here. And I have the finished sides here and here, so I know when the finished sides are oriented this way, the dot goes in the back. Now that I'm using these vice jaws with the grip on them, there isn't a hard stop on the back because it can move a little bit depending on how hard I clamp this. So I want to pick up the Y every time rather than relying on what I had in there before. So that was a really interesting project. I didn't film as much of the process as perhaps I would have liked because I finished the 2 molds in a weekend, and I also did another piece which was a riser that I'll describe later. There's another element of this that I'm going to describe in a future video. It's something I'm experimenting with, which is, for the injection molds, when they're sitting in the Morgan, what I've done in the past to get them apart is to put some 2-flats for a screwdriver so that I can twist and separate the 2 mold halves, because it takes a little bit of force to initially separate them. What I'm trying to do, and Jack is going to try it with one of the molds at least that I sent him, is to have the mold bolted down to the lower platen of the Morgan, and then there are some push rods that will come up when the platen lowers that will push up on the top half or the A half of the mold to push them apart. So I'm going to experiment more with that in future videos. Anyway, I hope you enjoyed this episode. Please subscribe, give me a thumbs up, comment below, and I'll see you next time.